Today I'm talking about something RISC-V or advanced AI or hardware innovation, whatever around RISC-V, and to do AI stuff. And I will talk next on the general compute and more focus on AIs. So myself is Liang, and I'm a software guy. I'm literally a virtual machine guy, putting Java virtual machine onto PowerPC, MIPS, and all these, and even ARM went back into Nokia. So I'm the founder of DeepComputing. And it's founded in COVID. I got nothing better to do. I sold my software startup, and then I started doing hardware because Shenzhen, I was locked down in Shenzhen and Hong Kong, random lockdown. So I got nothing better to do but electronics. So and then I still remember RVI CTO Mark Himmel, and then tell me, can you do something for RISC-V, make electronic or whatever using the SoC to whatever. When you're in Shenzhen lockdown, you might have a lot of friends there. So that's the reason. So I'm a software guy. I'm serious. If I'm serious about software, so that's why I'm here. Then I stupid enough, wasted all my money to make hardware. And I said to James, I'm not sure here, James here, we have a conversation saying that if we know hardware is so hard 4 years ago, I would have not done it. So hard, just too hard. So what DeepComputing does, we make consumer electronics, but only using RISC-V. So we make the tablet, we make the smart speaker, we make the router, and most importantly, we make the most expensive RISC-V laptops. Someone don't know about me, and then the drone and RC car. I remember there's one good old friend from Germany saying that they bought 2 RC cars. So that is what happened 2023, a 4-core 1.5 AG DDR. First one, usable, very slow, Debian, I remember it's Debian 12, and it's very slow. Oh, sorry. And then 2024, and we have all the distro support, and with a vendor kernel. So, and the story with Canonical is very funny. When I do the laptop, I ask them, can you support this? No. The sales team telling me, can you give me $1 million? $1 million and wait for me 9 months, and then they'll give you a distro. Say, oh man, I don't have money. But now they are fully support. They know the importance of RISC-V. I'm so glad all the support from the distro, except Android. So I think RISC-V journey is really hard. Everybody knows x86 isn't easy anyway. So back in the old days. So now they take on to internet bubbles. Like Google, they're using x86 board, PC boards to make with Linux server. So they get on it and get onto the server. And then ARM on the mobile side from Nokia. When I was in Nokia, I in charge of the Java platform for Nokia on the feature phone. So we have all the ARM chip, ARM 7, ARM 9, ARM 11s. And the high-end ones, ARM 11, not even Cortex at the time. So, and Nokia used to have everything, not relying on anyone from the SoC before they collapsed. So back in my old days, Europe has everything. We have a modem, we have Symbian, we have S40, S30, whatever. Nokia have everything. Have the backend and the network, everything. So that's the ARM. They gone up, But we are arrogant, we lose the smartphone, real smartphone. And RISC-V, I don't know. Seriously, when I look at the chipset, all the chipset makes money now from the ARM side or the x86 side is Windows and Android. And RISC-V, how do we going to survive? I think I only talk about AI, because AI is the most, I would say, the revolution of productivity. So we talk about AI. We all in AI. So that's why, even though I know RVA 23 is coming, but I still doing RVA 20 chips because they have a very strong compute. So why I like doing RISC-V? Because we can't be worse anymore, you know. And x86 is from US and comes back and driven by US, and it's very close source. They fight like hell. So I think some of the Chinese company managed to license out from VIA and have all the x86 or AMD chips, and they're all driven by US. And ARM, after I left Xerox and joined Nokia, we helped ARM to grow. I still remember we buy Nokia share, we buy ARM share, because we know how much Nokia giving them. But at that time, I remember ARM's market valuation 1 billion only. It's around £1 per share or something. And we see that at that time, we can see the hardware ecosystem. ARM, in license to, at that time, still have Motorola or TTP-Com, whatever, and the people, and TSMC, UMC, and in the old day, predecessor of Global Foundry, Charter Semiconductor, they make CPUs. So ARM licensed out the IP, and Nokia made their own CPU as well. So we will see that the whole industry from vertical, privately owned to becomes spread, owned by the individually by the player in different layers. So IP is ARM, and then Synopsys Cadence gradually grow, and then the fab majority is UMC, TSMC, and Charter Semiconductor. So this is very open, become semi-open industry. And then when we look at RISC-V, originally from US, now it's in Europe, it's Europe, you know. And that's the great thing I think David Patterson has done, moved everything away from the long arm. Probably he knows a lot of things we don't know about US defense. So, and interestingly, all the SoC is driven by Asia. You can say all the SoC I do now is all from Asia. So I think they taste the sanction for ZTE or Huawei that they are no longer be able to make any ARM SoC new spec, ARM v9 or ARM v10, whatever. They started embrace open ISA. So I would say I like about RISC-V. My analogy to Linux kernels belongs to anyone who knows it, right? If you are if I know how to do CPU, then I just make a CPU, and we have a lot of open source IP. It's not perfect, but you can make it on your own, and you can put in FPGA. You can control certain things. So it belongs to everyone. A lot of company, a lot of government, regardless the government is left or right, you know. So, and the other thing is that I think I said to James and say, RVA, no worry, RISC-V is going to grow. And I see the growth. For me, now, my company already passed selling 1,000 device stage. We're aiming at 10,000. Once we hit 10,000, we are break even. That becomes a business. Then it's going to grow. Every year, we see the growth. And then we see the performance grow 10 times as well. So that's the interesting thing. And the other interesting thing is that the dream is really big. You know, for all the young kids, you know, I give a lot of talk across the group, go to the university. For the young kids, I think RISC-V, good thing to RISC-V is that you really pay with all the famous and good people with a great heart, open heart. Just like in this kernel, you know, and they will be willing to lead you, help you to grow. And the other dream is that we're on the bottom, RISC-V. It can't be worse. It will get better. right? That's the compliment, I would guess. And that also call hope. And is compared to Intel, that's far different, isn't it? One is on the top going down, we're on the bottom going up. So one has hope, one has what? Desperate. So that is the interesting thing. So we even though it's hard, but we have hope. Hope let us work even harder. So, and when I read back how I've used need three, four, but one cannot be mass produced on the main board. And we see that the RISC-V SoC now, just before AI comes 2 years ago, before LLM, before ChatGPT, seriously, I don't. RISC-V guy have no idea where to go in high performance SoC, high margin SoC. What I mean high margin SoC is not any of the closed system, MCU, whatever. It's need an open ecosystems SoC, like anything above $10. So it's a known market. That's why all the SoC guy design from the test chip TH1520 is very complex SoC test chip to Starfire's J11, J7, 7110 is very complex SoC with limited manpower. So because they don't know where market to go for consumer electronic industry, they don't know. So they put all the IP inside. It's very complex. And the second thing is that when RISC-V mostly is done by the startup, and because you don't know the industry and you don't know what compute power you need, that's why we have 4 core, and we still have 4 core, but now we have another new technology can combine 4 core becomes 8 core, but they don't know the compute. Everybody is gambling, but for 20 nanometers, it's okay. It costs you probably $2 million, $1 million to tape out, but the R&D cost probably still need 10, 20 million. So for a startup, you have limited resource constraint to go. That's why you will see that Starfire haven't got next generation of RISC-V high-end SoC, and eSpring as well, because the current one, they are not selling well, then it's very difficult to justify the last one. Because everything you double down, 20 nanometer, you need 5, 10 million. And then if you do 12 nanometer, you probably need 30 to 50 million, including R&D costs across 3 years. So it's very, and the other thing is lifetime, the limited time constraint. You think about it, RISC-V is 15 years to get RVA23 out, and Sci-Fi been 10 years, and that the rest of them are 7 years. Even DeepComputing only getting to 4 years. So we have a lot from the shareholder, the investment, we have a lot of time constraint on us to break even. So it's lucky that I see the AI comes help, and that's why we say we all time to all in AI, not any other things. But when we look at the AI side, we find out after we've done this chip, later on we talk about it, we don't have at the moment, AI is on the server side is very hot. But on the device side, even Qualcomm, AI PC, right, and even the mobile, they have no idea how to use AI yet. Right? There's no killer application. There's nothing that can dominate our life, be carrying it. So, and then the model side is not good enough yet. Right? Because it's been changing from AI 1.0 to 2.0, so from the small ResLab transformer now to DeepSeek, whatever, right? And the framework is even worse, probably. CUDA is dominant. That's why you have trillions, 4 trillions of market evaluation, and PyTorch as well. So, and once the AI come out, we have a lot of framework, new framework, Llama, Ollama, Whisper, right? and webLLM as well. So there's a lot of work on software. So I find it out when we do hardware, actually software is very important. And back to the hardware guy, what we can do is porting, you know. And I think Dewitt knows it, right? In TensorFlow, we're porting and porting and porting, keep porting. So endless, right? So all the framework. And then the painful of the SoC, high-end SoC, you know, from IP SoC to board like us, it's very complex. Software application, you know, the cycle, the chicken and egg cycle, it takes about 5 to 7 years. Right? The E-swing chip I use is P50. P50 is, that IP is 5 to 6 years old. And now to the board, now September, mass shipping, 6 years. We still haven't got the OS yet, official OS yet. But we lucky get Ubuntu's help and give you render versions. I don't know, you know, then when I look in the AI, and then I would think that because we don't know so much unknown, we had to make everything a retrofit. We call it Lego. So it's a new technology. So from the IP side, and then we have the die side, we have IP, and then we have die SoC, and then from the SoC, outside SoC, we have PCIe hosted device, and then from the board side, like look at our framework board, everything's Type-C. Then one good thing Europeans have done is Type-C. One body good thing we have done. Because we can't even unite the power plug, isn't it, in Europe. So, but Type-C good. So in the product level, later on I'll show that how why framework is going to be good. So take a look, the E-swing, I talked about it in Boston as well, but at that time it's not announced. So you can see 2 chips. Now I'm putting 4 chips in the mini ITX. So that's a very flexible. We don't know what market is, and we don't know how much compute we need. So now we can bundle it, and also they have a PCIe host and device. So it can be a car, and it can be a motherboard. Sorry, we are not allowed to say. And that is the 4 core. 4 core becomes 8 core. And then I have 4 coming like that. And then connected by PCIe bridge. So we can make a car, something like that. This is something like that. So this is another AI car with a lot of compute, and then I make that as a mini ITS mainboard. So it's good fun. In the other side is my framework motherboard. So I used to do my laptop, so I giving up. So I partner with frameworks. One of the greatest inventions in going backward. We used to build we are old enough to build our PC, but I don't think nowadays the kids build their PC, they buy laptops. But Europe, I think in this, the DIY stuff solutions. So it's good. So Ubuntu support us. Now we need to work for RVA23. So next year is everything in 2604. Once we sort out upstream, you know, Drew and all the kernel guys help us to get the upstream done. It's going to be 2604. Official from Ubuntu, not from me, not from the SoC guy. And, you know, Ian Grad is the support. After I found out I cannot solve upstream, I asked, all these old people knows more than I do. I say, why upstream is so hard? They say, it's because it's ARM. And you know, and recently Red Hat is moving on as well. So hopefully your RVA23 upstream is done, Fedora, CentOS, and then Red Hat, we were all on it. You know, and that's my hope. And that's, I say, right? Because now RISC-V is not high volume, even my product has to go by retrofit. That's why I stopped doing my laptops, because I make motherboard a new motherboard every 6 months. If you buy my first generation laptop, I send you a new motherboard, you can't do nothing with it. Right? You can't do nothing with it. But you don't need enough invented a DIY laptop. You can upgrade it, you can upgrade it, you can upgrade the model, you can change it and fix yourself. Right? So, and also we can share the motherboard 12, 13, 14 inch, 16 inch is not sure yet. So, and that would be so great. That means that I can make one board fit a lot of categories. So that is helping me, the volume is not going up. I can share the volumes. If each one I had to make a motherboard, the NRE fee probably kills me already. So that is the RISC-V. Yeah, we have 64 DDR, we have a 50 TOPS AI. It runs, if someone you're interested can go to our machine to run the 7B models. And 4.3, 4B, the all run okay. And it's very affordable, right? The cheapest one is from $299 onward, it's the motherboard itself. So, and we do have a plan on this low end of 12 inch. So when we decide that, my hesitation is still RVA 23, right? So, and that's very affordable. You know, we push it down $200, so hopefully we get there. And then this is the AI machine. So just now I saying that I might put a full AI machine on it with maximum 32 core. Just now it's 4 chips. And with 2056 LPDDR, people can run one 70B models, and probably even more 120B models of OpenAIs on the price of $100. So you can take it home, put it home, and run all the model yourself, and put an agent around it, you know. And if you want, you might be able to do fiber connect onto our PCIe and the 90 side to connect it to run the full-blown full block of DeepSeek. So it's very interesting, with affordable. I think this is only what, 1/3 of the NVIDIA cost. So the other thing I might do is that I might do RISC-V, I will total or extendable together with the x86 main board all together. So you can carry this 16 inch with 2 architecture there. One runs Windows, the other runs Linux and RISC-V. Do whatever you like. But you probably had to wait for the volume to pick up so that I can get some money out of it. So still very affordable. So this is the roadmap I see. I've done Q2, released the 4-core, Q3, released the 8-core, and then Q4, I said to Fabio, there's 32 core coming with AI. I then do loads about it, and we work very close to the Tenstorrent to get their AI car full running on the RISC-V host. And then definitely we're planning mini ITX so that people can have freedom of AI. So, and what I'm going to talk about is that you really need, now I think the hardware we're getting there, but the software is so bad. The software is so bad, that's why I come to all the open source summit, help you guys to help us. You either give us request to buy my hardware and tell me what to do. Just like Bruce telling me, I want GIS. I order 100 machines, will you point GIS? Yes, I will put GIS on it. Right, that's one the thing. And help me to focus what to fix, because there's too many things to fix. Now, for example, Duo and Andy or Greg saying that we had to get sorted out the upstream. So this year, let's sort it upstream. I provide all the hardware, I provide all the facilities to get upstream done. Right, so use it, feedback, and contribute. As I said, right, now I give you an example. Even Chromium doesn't have a RISC-V build. on their CI. And they're not accepting the patch. And Chromium has 200 libraries with ARM assemblies. And no one do nothing about it. And no one afford to do anything about it. So all we have to do is same. I think Fabio and me knows that we need a very good single core performance. I didn't do TensorFlow and understand it. The software is bad. We need very good single core performance SoC to get the gap. On the high side is the open source community help us to improve all the 200 libraries. I remember I spoke to the training company. You should talk about how do we convert the ARM assembly to RISC-V assembly. And that will help everything. Then, and also, because RA23, we have so much major extensions. Just now, we have all the AI.cpps in needs porting onto the new instructions. So we need a lot of software, I would say software bodies, some bodies, so bodies, moving bricks to get it done. And kernel as well. So kernel upstreaming, we set it on the virtual team, let's get it done, get it over. We have a proper distro, and then a Scaleway, Fairbuild. It doesn't need to worry about future OS upgrade. Otherwise, he buy a 10 server, what I'm going to do about it, right? If you don't upstream, who's going to support the upgrade of OS? It's another dead in the old day history. So we launched a program. I decided that this 2023 and 2006 is up us to at least reach 10,000 users daily on RISC-V. So I create all these programs, and with 100 school, university, and all the kids, to just same as ARM, back in BBC, remember the BBC mini computers, right? They're all on ARM. I think I back to old day. We need to back on the students. So, and we want at least 1,000 new students knowing RISC-V and joining RISC-V and helping me to move bricks, solving Bruce's problem, and make with AI as well, make the documentation better, porting procedure, training better, right? And then hopefully you get 100 good one to support our future RISC-V, a few decades coming. So this is our sponsorships. So we have a free course of IP, SoC, board, product design, and we give a free course all the materials and BSP integration, AI integration, everything. And we also give the hardware away to the kids if they do make it. And then that's how we do it. And trying to help the kid hackathon, internship, supply train, all our friends here. We get all the kids out, right? So, and I do appreciate RISC-V. It has the brand. I feel that because it's openness, so far, I go around open source. Everybody is willing to help, either one way or the other. Either buying my device, give some money, either doing the work for us. And of course, for the kids, especially, I don't know how many kids here, and it seems it's open source summit is getting old, not enough kids. So we need to fix that. And the other thing, we have open community project, another project probably GIS, OpenBow, and OpenBow will be there. And we have GIS, and then we have AppCode, and some OpenScan code, all these community project, and LVM, we're going to have all the sponsorship same. We want 1,000 contributors across all the projects to make, for me, it's just giving hardware away. And then when it gets better, people are going to buy it, when the software gets better. So that's how I see it. And then hopefully we get all these community projects with very good contributors. Anyone you guys free and helping hands on the project? Yeah, it's just a part-time. I think a part-time effort is good enough. And yeah, it's going to be all these devices. And then we'll do AI, because we work across all the RISC-V AI accelerators, especially Tenstorrents. We're going to sponsor all the AI startups and so use our hardware, help us to improve the whole stack. You know, when I look at currently all the RISC-V accelerators, they all lack of the software capabilities. For example, PyTorch is not fully ported, and Llama CPP, webLLM is not fully ported, Whisper is not fully ported, and when we have a matrix instruction, that's not fully automated. So we need those AI guys and to do something about it. And that will be the machine. So we got some of these machines selling out, and yeah, same. We will probably give some of the Tenstorrents Galaxy out. And also, if you're in the cloud, the free token out to do something. So, and that is the thing I did talk about. And back to what I want to say is the AI side, I think is probably I will see that the only opportunity that we can conquer before things get better for RISC-V. The only thing might help us. For as I said just now, for non-AI sector, it's very difficult to compete. We evaluate, if we do a 12 nanometer chip, we had to sell 1 million chips to recover the cost. But if we do 6 nanometer, we had to sell 3 million chips. So 3 million chips, you need to support 3 million chips effort, the R&D effort, altogether, probably need 150 million. So it's not an easy business for the conventional market, non-AI. So if AI side, you can see just now, if you put an AI mini ITS, I can have 32 core, 4 8-core chips in it, and with a lot of compute. And they can be a general desktop, it can be a general industry desktop, but with all the AI in it. That will consume a lot of chips in one form factors. If we rely on me selling laptop in 3 millions, I think I can sell a laptop for 3 millions. So far, there's no Linux laptop for 3 million from HP, Dell, Lenovo's, even on ARM, or even on x86. Right, so that's why I say all in AI is very important. In going back to my plea is that this, we had to help me to solve not just let me going back what you guys need to help on is the AI stack. Where is it? The stack is very important. I think the AI stack you need to help is this stack. This is humongous stack. So this year, hopefully we solve the kernel side, right? And then distro side, and then this all on top. I'll give you an example, right? And now I think Red Hat, I don't know whether what Red Hat is 6.1 kernel. I think OpenCL is on 6.6 kernel. 6.6 kernel is very old. You need to support all these framework. It's a humongous task to backport. So this is the key for our AI to move forward. And then you can see we have opportunity to do something like Chrome, Web GPU, Web MPU, Web RISC-V extensions, there's no opportunity on the framework side. So, and if AI is the only thing left, we definitely need a new bunch of software guys help us to improve everything from the X all the way to the framework and to the libraries. And that's all for me today. Thank you. It's not a hardware issue, it's a software issue. Thank you. And any questions? Yep.
Have you numbers of comparing to NVIDIA? So what is performance your CPU?
I would say that hands-on hardware is getting there. You look at Tenstorrent doing it's 20 spec in. 20 spec in is the equivalent M1, Apple M1. But without the software, you're still slow. Right? For example, the browser, you have 200 library of assembly, vectorized, optimized code. If you don't sort it out, scalar is not going to give good performance. Right? Even though you have a spec in single core performance. Right? But software is still the key to resolve. And hardware is definitely getting there. We see the roadmaps, 4 nanometer, 6 nanometer, right, 12 nanometer, 16 core, 32 core, all coming. It's just people have to help the software. If the software doesn't improve, there's no mass production, there's no mass sales. Right? That's how I see it. I think Scaleway, Fabio can talk about it. Why you want a RISC-V if you can't maintain, right?
And the thing is very difficult to compare performance between different GPUs due to software, because software support is so different. It makes comparing performance and benchmarking very, very difficult.
Yes, because even the GLMark or Geekbench, because they're all software. The software is bad. The compiler is bad, right? So far, very interestingly, for LVM, we still haven't got the like-for-like comparison. How many pass, optimization pass against ARM or against RISC-V? I haven't seen the roadmap, I haven't seen the plan. So it's ready. If a compiler doesn't do good, what else you can do good, right? Your software, the performance is going to be crap, right? So, any other more questions? You know, Michael is not feeling happy about keep doing reverse engineering on the GPU side. Yeah.
Yeah. You know, with the software ecosystem, there's this RISC initiative, right? So multiple companies are collaborating to actually get the libraries working and the kernel. So this is happening, right? And the big corporations are doing that, right? So
Exactly. If the community is there, it's just slow.
I mean, things takes time to figure out, right?
Yeah, exactly. Just like me, it took me 4 years. If I know it's so hard to get an OS on it, I would have. I just back off. I'm not doing RISC-V. But because I'm stupid enough saying that, I can get it done too next year. Right? But it's interesting. But we're moving there, right? Dude, let's get the upstreaming done. What the hell? Otherwise, we're all dead. Anyone else? Anyone else? Then we call it. Okay, a day. Thank you. Thank you.